These USB chargers have almost the same specs, but they are made by different manufacturers. Today I'm going to examine which one is better. For this video, I searched for chargers with a foldable plug, one port for output, and about the same size. There were two manufacturers that met these criteria, Anker and UGREEN, so I chose these two chargers. There are some small differences, but the specs are mostly the same. The only difference is the price. Does the more expensive one have higher quality, or is it basically the same thing as the cheaper one and the extra price is just for the brand name? I'm going to find out through performance tests and disassembly. These are the USB chargers I'm going to examine. First, the Anker USB charger, Anker 511 charger, Nano 3 30 watt. And here is the other one, UGREEN USB charger. I don't know how to pronounce the product name, something mini 30 watt charger. Let's take a look at the appearance. I chose them because they were about the same size, but when you compare them closely, you can see that their sizes are quite different. This is how they look. The Anker one in my left hand is smaller. The UGREEN one uses a gallium nitride power semiconductor, so-called GaN power semiconductor. The Anker one doesn't mention anything about GaN, but it probably uses GaN because it's so small. As I said, both chargers have a foldable plug. The plug of Anker Nano 2, the previous model of this one, was not foldable. This Nano 3 30 watt is the first model that has a foldable plug. I'll briefly introduce the specs. Both of them support USB PD charging. They are both 30 watts. The Anker one can adjust the output voltage. It says PPS here. It means the charger can change the output voltage from the PD voltage. Now let's check the performance. I calculated the power to volume ratio and the power to mass ratio, which indicate the performance of a device. I made a chart. When a charger's power per volume and power per mass are high, you can say the charger has good performance. By the way, you can also check these figures in another video where I disassembled USB chargers. Please watch it if you like. There's a link in the description. Let's check the weight. The Anker one is 38.7 grams and the UGREEN one is 49.8 grams. But when I hold them both, I almost can't tell the difference. This is my opinion, but I feel like they weigh almost the same. As for the volume, the Anker one is 28.8 cubic centimeters and the UGREEN one is 42.8 cubic centimeters. The Anker one's volume is smaller by around 33%. The next row is power per volume. The Anker one is 1.04 watt per cubic centimeter. The UGREEN one is 0.7 watt per cubic centimeter. Again, when a charger's power per unit volume is high, it has good performance. If the number's higher than 1, the charger is quite powerful for its size. As for the power to mass ratio, the Anker one is 0.78 watt per gram and the UGREEN one is 0.6 watt per gram. Now let's take a look at another performance indicator, conversion efficiency. Conversion efficiency indicates how efficiently the charger can convert the AC voltage from the outlet to DC voltage for charging. The higher the efficiency, the better the performance. So if you want to know the quality of a charger, you should check the efficiency. Let's look at Anker first. For this amount of output power, the efficiency is high. The efficiency is mostly higher than 85%. The highest is 90.2% at 15 volts. It's higher than 90%. Many chargers' efficiency is the highest at 20 volts, but this charger's efficiency is the highest at 15 volts. Even at 5 volts, the efficiency is quite high. A 30 watt charger is often used to charge devices that don't support high power. Such cases may have been considered when designing the charger. Next, let's look at UGREEN. The result is similar to Anker. The efficiency is mostly higher than 85%. The highest is 89.9% at 15 volts. Compared to UGREEN, Anker has slightly higher efficiency. When you compare these efficiency graphs of the Anker charger and the UGREEN charger, they look almost the same. Judging from that, I suppose almost the same circuits are used for these chargers. I'll check the circuits later when I disassemble them. After measuring the efficiency, I also measured the temperature. I measured the temperature when the voltage is 20 volts and the power is 30 watts, assuming the usage at full power. I used a thermocouple and a thermal camera. Both of them showed almost the same results, but the thermal camera's result was 2 to 3 degrees higher. Also, the temperature was measured with measuring tools inserted like this, so it also needs to be taken into consideration. Therefore, I'll show you the measured temperature just as reference values. Let's start with Anker. The Anker one's temperature distribution is uneven. The maximum temperature on the side was 64 degrees Celsius, and on the top, it was 78 degrees Celsius. When I touch it, it actually feels like that. However, plastic has low thermal conductivity, so it doesn't feel that hot when you touch it. Occasionally, I receive comments asking me to make a USB charger with a metal case. Metal has a high thermal conductivity, so when metal and plastic are at the same temperature, it feels hotter when you touch metal. You may get burnt when you use a metal USB charger. Also, compared to plastic, metal is harder to insulate, so there is a higher risk of electric shock. For these reasons, it would be difficult to adopt a metal case. Next is UGREEN. The maximum temperature of the UGREEN one is 64.5 degrees Celsius on the side. The UGREEN one is larger and has a wider surface area, so it has an advantage in terms of heat dissipation. On the other hand, the Anker one has a smaller surface area, so heat is not dissipated well. These chargers are small, so I think the heat dissipation from the power strip and USB cable accounts for a large amount of the whole heat dissipation. I'm sure it does. Finally, let's measure the switching frequency. I'll show you the disassembling video later. For now, let's measure the switching frequency. When the switching frequency is high, you can use smaller passive components. However, the trade-off is that higher switching frequency means larger switching loss. I measured the frequency at 20 volts, 30 watts. Let's look at Anker first. This waveform is measured on the secondary side of the transformer. The switching frequency is about 120 kilohertz. Instead of the value at the top, look at the value at the bottom. As you can see, it's moving between about 120 and 130 kilohertz. Next is UGREEN. This is the waveform. UGREEN's switching frequency is about 85 kilohertz. And that's about it for the performance inspection. As a result of the experiments, I think Anker has overall higher performance, except that it gets hotter. Now, let's get into disassembling and look inside of the chargers. Disassembling is done. Let's take a look at the internal mechanism. For both of them, the foldable plug takes up about 20% to 30% of the whole volume. Let's look at the circuit. The circuits are quite small, especially the Anker one. As you can see, the component density is quite high. Especially the Anker one in my right hand has a high component density. In order to efficiently place the components in the limited space, two printed circuit boards are connected to arrange the components three-dimensionally. I measured the switching frequency earlier. In principle, higher switching frequency allows the use of smaller components. UGREEN in my left hand switching frequency is 85 kilohertz. Anker in my right hand switching frequency is 120 kilohertz. Because Anker's switching frequency is higher, the passive components in the Anker one seem to be smaller. However, the conversion efficiency was the same for both chargers. The power loss is about the same, but Anker is smaller. Therefore, Anker tends to get hotter. The temperature of the Anker charger was actually slightly higher. I found it out when I measured the temperature of the chargers. Next, let's look at the board. On this board, a power semiconductor is mounted. It plays a key role in power conversion. The power semiconductor on the Anker board says 3606HR051. I searched for its datasheet but couldn't find it. Next, let's look at UGREEN. The power semiconductor is mounted beneath this thermal conductive sheet. It says 9584F1P1. I tried to find the datasheet, but couldn't find it either. If these power semiconductors are made by major manufacturers, you should be able to find the datasheets easily. My guess is that these power semiconductors are made by Chinese manufacturers. The UGREEN charger says it uses a GaN chip in the description. The Anker one doesn't say anything about GaN, but I think it uses a GaN chip because it's so small. But I couldn't find the manufacturer, so I can't tell if it's true. Until about a year ago, gallium nitride power semiconductors used for this kind of AC adapters were mostly made by Power Integrations, an American manufacturer. That trend has been changing recently, I guess. Let's have a look at the Anker board. Two boards are used. This electrolytic capacitor was placed here. Its manufacturer is Chengx. The maximum temperature is 105 degrees Celsius. Other electrolytic capacitors are also used, but all of them withstand 105 degrees Celsius. You can separate these two boards like this. These two boards have different roles. The left one handles high voltage, and the right one handles low voltage. Actually, the circuit on this part handles high voltage, but it's very close to the low voltage circuit. A plastic shield covers the board to insulate the high voltage circuit from the low voltage circuit. This black pot. Actually, the structure of this part of the shield is so cool. Let me explain. In this shield, there's a cylindrically shaped part. Actually, there's an electrolytic capacitor inside. In order to mount it and insulate it, they made it possible to move this part. The shield is off. If you mount this electrolytic capacitor normally, you can't put the shield on it. Therefore, they did something special. Firstly, this electrolytic capacitor is soldered at the legs. Once the electrolytic capacitor is soldered, the shield is put on it. When the shield fully covers the capacitor is pushed down. This is how they assemble this part. They used quite a tricky technique here, didn't they? After all the components are mounted, insert the connectors in the holes in this way. There you go. Height. Finally, solder this part where the boards are connected to each other. Then the assembly is complete. Also, you need to fill it with silicone. I've been disassembling AC adapters for a few years, and I found that small AC adapters especially require a lot of work for the design and assembly. Next, let's disassemble UGREEN. This one also has two boards soldered to each other, so you can separate them from here. There is an insulating sheet here, which insulates the high voltage circuit from the low voltage circuit. By the way, this board also has both high voltage circuit and low voltage circuit on it. When you remove the insulation sheet, it looks like this. There is a big slit here, so you can bend the board easily. There are the terminals. They are for the voltage coming from the outlet. From the terminals, the voltage goes to the other board, where it's converted, and then goes out from the USB output. Just like Anker, high voltage circuit and low voltage circuit are implemented on a single board. This slit plays an important role in insulation. The circuits are insulated by air thanks to the slit. Moreover, an insulating sheet is inserted here. This slit is vital for insulation. Let's look at the boards in the assembled state. It gives an impression that there is a lot more space in terms of component density compared to Anker in the UGREEN charger. The components are packed for sure, but compared to Anker, you can say there's still some room. The electrolytic capacitors used in this charger are made by Capson. Both are made by the same manufacturer, and the maximum temperature is 105 degrees Celsius. To summarize the difference between Anker and UGREEN, Anker is better at arranging parts three-dimensionally. Their implementation is quite sophisticated. Or rather, I think it was difficult to achieve such a small size unless you put a lot of effort into designing the component layout. On the other hand, UGREEN's design allows a lot of space between the components. There is still plenty of room to make the product smaller, but it's highly likely that they chose this design to achieve better insulation and heat dissipation. Now, let's go into conclusion. I disassembled chargers from Anker and UGREEN with the same specs. The performance was almost the same, but we found out that the structure inside was completely different. You may want to know which charger you should choose. Actually, whichever's fine. The performance is almost the same, so I think you should buy the cheaper one, or the one made by the manufacturer you prefer. If you want a small charger, choose Anker. But I'm not saying UGREEN charger is large. It's quite small for its power. Another point is the price. I think you should decide based on whether you want a small charger or a cheap charger. So I disassembled two USB chargers from well-known manufacturers. If you found this video useful, please like, comment, and subscribe to our channel. Thank you for watching.